Hello everyone, welcome to this channel. So in this channel we are going to talk a lot, we are going to code a lot, we are going to understand a lot, uh, right from problem solving skills to DSA to understanding systems and gaining everything that is required to move forward in your career, to crack interviews, to reach where you want to be. We are going to go through that journey together. So, if you are someone who wants to understand code, who wants to understand problems, solve it on your own, and not just copy paste code, hit that subscribe button and let's get started. So here we have drafted a DSA sheet. I spent a lot of time putting together problems here. This may look long at first, and this is long, and that is how it is supposed to be. So basically, in order to understand larger problems, in order to understand complex problems, we need to have a solid foundation. For example, in order to understand dynamic programming is basically caching subproblems on top of recursion. So we have to have an idea on what recursion is. So yeah, generally to understand recursion we need to know graphs, we need to know how it branches out. So to understand complex problems we need to have a solid foundation. Likewise, here for that note we start from the basics. We start from arrays, hash sets, everything, linked lists. We build on top of one another. So, likewise, we go up until dynamic programming, segment trees, everything. This is going to take a lot of time, but it will be worth it. And I am committed in solving this. Anyone who is committed also join along. So we also have a progress tracker here. This progress tracker is basically we are not going to paste code here. We are only going to make a note of what all we have completed up until then, and I will be adding YouTube links here for the videos that are completed. Yeah, we'll get started. So the first problem will be LeetCode 3, and that is longest substring without repeating characters. Given a string S, find the length of the longest substring without duplicate characters. Okay, first of all, we need to know what a substring is. So there are two things basically, substring and subsequence. So in order to understand the difference between them, A, B, C, D, E, F, G, H, I, yeah, okay. So a substring is going to be C, D, E. Another example will be F, G, H, Y because they are continuous. C and then D and then E, like that. So ABC is a continuous arrangement of characters in this string, so it is a substring. Now to the problem, longest substring without repeating characters. So basically what they want us to understand, what they want us to code for is to find the length of the longest substring which does not have repeating characters in it. Yeah. So for this input case we have ABC. ABC has no repeating characters and it is a valid substring, so the length of this is 3. And CAB is another substring which doesn't have any repeating characters, also has the length 3. So the longest substring is of length 3, and that is what we will return. The same goes for this. It has no substring that is greater than length 1 without repeating characters. So yeah, the constraints are the length of the string is going to be from 0 to 5 into 10 power 4. 5 into 10 power 4 can handle up to on square of operations. Okay, so what is the sliding window approach? Uh, it is basically that we slide through the input, uh, growing the window and shrinking it as required. Yeah, so assume that we have a test case A, B, sorry, B, C, and again a B. Yeah, so assume we have this window and a hash set. This hash set is basically going to store if that we have seen this letter already or not. Also, we have a counter. This counter initially is going to be 0, and we have the letter A inside the window. What it means means is we have brought the letter A into the context of the window. That means the window has grown one letter. So we will increase the counter to 1. Okay. Now also we will put A into the hash set. Now since the hash set didn't have A before, we can move the window and bring B into the context. So since the window size is now 2, we will make the counter to be 2. Likewise, we'll also put B inside the hash set and bring C inside the window. Now the window size is 3 and hence the counter will also become 3. Now what happens is when we bring B inside the window, we check, oh sorry, we should have put C inside the hash set before. Now when we put bring B inside the window, the letter B is already inside the hash set. So what it means is basically we have seen this letter already in the present current substring. So we are processing a substring. We are trying to identify the longest substring, and in that process we have found a letter that is already been seen, which means that there is a duplicate that is existing. So what we now know is we should in so basically the longest substring that is possible up until now is 3. So what we do is we are going to be positive. We are going to think that there may be a different substring. So that means we are assuming that the test case is not yet completed, and we assume that there can be a substring which is greater than 3. So what we do is we will remove every character from the window that is before that is from and before the duplicate entry. So the duplicate entry now is B. So we will remove every character from the window before and from B. So now the window size will be 2. Okay. We also will have a final result variable, say result. This will store the longest result. Okay. So now the substring sliding window size is 2 and the test case has come to an end. So our window will basically close. So the result is going to be 3, the longest of the two results. Okay. Now we will try and code it out. So what did we need first? We needed a hash set of characters. Yeah, set. We'll call this a set, hash set of, need this here. So yeah, okay. We need a start. Where do we start from? We need a result. Result is going to be 0 at first, and so int I is equal to 0 to s dot length and I plus plus. So char letter, we are taking the current letter from the string, and first we should see that if this current letter is inside the set. If set dot contains letter, yes. So we'll come to this part later. If set contains the letter, we'll come to that later. Yeah. So if set doesn't contain the letter, what we are going to do is we'll put it inside the set. Okay. And we'll put it inside the set, and yeah, that's all we are going to do. Now, if the set is going to contain the letter, what we will do is we know that a duplicate is now found. So we are going to remove all the characters from the hash set from the start, the from the start index up until we find this letter. Okay, yeah, makes sense. So while start is less than, yeah, no need equal to. So while why did I even think about that? Because should we iterate the hash set from the start? I mean, should we, where is that, yeah, should we come from this to the current letter or the before letter? So what I figured out is it is enough that we go to the before letter. So if we come to the current letter, that is not going to make sense. Yeah. So from current start to I, what we are going to do is set dot remove set dot remove s dot cat. Now what we'll do is we'll also have populating the result. The result is going to be the maximum of itself or the current window's length. The current window's length is basically I is the end, right? So from end minus start is going to be the length. Okay. Mm, while completing a return math.max result. Okay, let's see if it works. Oh, sorry. Yeah, it did. And now we are going to submit it. It failed for this case. Why did it fail? DVDF. DV. The output is 2, but it should have been 3. Yeah, that's what I did. So this is for max. So there is a one small thing that we missed. We should have broken out of the loop if we had found the letter to be equal to the duplicate, right? Letter from the window. What do I mean by that? So basically, we have a window here. We should only remove the characters from the window up until we find the same duplicate letter. Yeah. So we missed that out here. So from the start. So what do we do? We are going to remove this from the set, and if letter from the window is equal to the duplicate letter, we will break. Yeah. Now let's try submitting. Yes. Okay. So we learned the sliding window approach by solving this problem. The sliding window approach is nothing but sliding through the given input. So the window grows towards its right and shrinks from its left. So that is how it is typically done, and that helped us solve this problem. For example, we grew the window towards the right until we found a duplicate character. And when we did, we shrank the window from the left until there is no duplicates. So that is how we typically achieved this. So this is basically, this may seem like not a linear algorithm, but this is a linear algorithm. So to prove that, so yeah, this is a linear algorithm where we grow the window and shrink it. Any doubts, please drop it in the comments. I will be happy to help.